It's 11 o'clock. We'll start the second session. I hope you can hear me out there, both the ones in the room and online. My name is Hans Peter Slender. I will be the moderator of this session, which deals with sector integration through Power to X and symbiosis. We came just out of a session which deals with district heating as a way of sector integration, integrating different sectors and energy forms. And now we change the zoom a little bit and look into new ways of achieving symbiosis and sector integration, namely through Power to X and other measures. So we have 4 speakers who will each give a presentation, and after that we have a dialogue up here, including questions from you in the audience. So I'm pleased to pass the floor to the first of the 4 speakers, Claus A. Nielsen, who is Head of Business Development at Din Forsyning, the utility company of SBR. So if we are in the EE capital of the world, I think SBR is called the energy metropolis of Denmark. So please, the floor is yours.
Yeah, thank you. Even in the SBR area, where is the new SBR Foundation and SBR agreement about outbuild of green power, even in this city, we also think energy efficiency first. So even that we can outbuild, and we have to outbuild also with offshore wind and other renewable powers, we also have to use the energy efficient. And that's really important. We have done that for many, many years, and we still continue to do that in the future, also when we have excess heat from Power to X, but also a lot of other. Because we are really designing the district heating network of the future. We have this low temperature district heating network, the infrastructure that is ready for PTX and waste heat in general. Also decarbonization. We are just right now integrating the world's biggest heat pump, centralized heat pump based on CO2, which can lead the forward temperature needed for all district energy networks with a bit below 100 degrees C. So there is no reason to say that you cannot decarbonize a modern district heating network. It's possible, also with heat pumps. And this is the next phase. We are integrating the first phase, but this is the next phase I will discuss today. Because the indirect electrification, that's the next part of the journey. But we are in the middle of the first part. And I can tell you, we are involved in different areas of Power to X. We are not building Power to X, we are not selling Power to X, but we are the infrastructure partner for Power to X. We are working on 4 specific Power to X projects in the SBR. I think there's no place, at least not in Denmark, or maybe not even in Europe, where there have been announced that many projects. If they are going to be realized, there's no final investments decision, but there's announced a lot of projects. And we can say that we will, and one of our collaborators is coming on the scene in a few seconds from European Energy. We will do the first Power to X integration to a district heating network real life in Esbjerg pretty soon. We have the agreement pretty close, I would say. Not signed, but pretty close. So we'll do it in real life in really soon. And some of the big projects, they are announced for ammonia, for whatever you can see. But we supply these 4 areas because Din Forsyning is owned by the municipalities of Esbjerg and Varde and covering the whole region there with drinking water, sewage treatment, waste handling, and also, of course, district heating, which is one of the basics. But I come back to, there's also a lot of other details in Power to X where you can have energy inefficiency. But we try to put in energy efficiency instead, and that's also about water. Because we have this ambitions in Din Forsyning, is to go to zero waste, will not waste anything. That's an ambition. In 2030, we'll have no waste in any kind of resources. So that's also an important goal. Fossil-free value chain, everything what we do have to be fossil-free. And also the last thing is flexible business and partnership. We don't believe that we can do it ourselves, but we have to provide business potentials to the area, to the companies in the area. We have to be an attractive area because we are owned by the municipality, and if you have an attractive area, people would like to live there, and you can do business there, and it's about also having the competitiveness of the area. So we also provide competition, efficiency on the competition levels of the industry in the area. That's also important for us. Then you can see that's quite easy, this power to X, because even whatever you have to, if you are doing methanol, you are doing hydrogen, you are doing ammonia, whatever, biofuels for airplanes, whatever, it starts with renewable power, water, then you get hydrogen, oxygen, and heat. That's simple. And we have the water, somebody else have the power. Somebody will take the hydrogen, and we can take care of this, the heat. That's simple, if the infrastructure is there. And the infrastructure is, of course, piping, distribution system, but also a lot of end users. So, as Kamstrup also said from the scene before, it's important that the households, the installation can utilize, because if you cannot utilize the energy, it's going to be wasted anyway. So it's the whole value chain that have to be efficient. And that's really, really important thing, that you have to have this vertical sector integration. It's not only the sectors between wastewater and heat and between transportation and energy, blah, blah, blah. It's also in the value chain of heating. You have to have the vertical sector coupling. That's also quite crucial and important, because you cannot use it if the end takers cannot cool the system, because the district heating network doesn't cool, the buildings cools. The cooling is in the buildings, not in the network, hopefully. Yeah, we are right now building, as I said, the world biggest. It would be around 70 megawatts thermal output of a seawater heat pump to decarbonize instead of having a coal-fired power plant. We are quite satisfied. We have some good partners doing really, really nice work, but we have also replaced 350 megawatts of CHP, coal-fired CSP, with only 70 megawatts of seawater heat pump. Then we have a little bit biomass. We'll maybe use it, because at that time when we did this decision, it was not possible to have the forward temperature with the heat pump technology. We got this, but we didn't know. But it had been developed by really, really good industrial partners that have done tremendous proceeds in getting good new technology to the world. That's really also a nice part of this project. But this project is also suitable for uptaking a lot of excess heat. We take excess heat from Power to X, from European Energy, maybe from Høst, maybe from H2 Energy, maybe for somebody else who wants to utilize this renewable electricity from offshore wind and solar. But we can take it. We can provide, even in the coldest days, we can provide 2/3 of our customers in the distribution system with only 70 in forward temperature. So it's not something that have to be developed in the future. It's there. We have some parts of our network, 1/3 of our network requires 80, 82 degrees for the distribution system. But the households, it's important that the households, as also Kamstrup said and others have been telling for Aalborg University have also made studies on this. The households, the buildings have to be efficient also to utilize. So it's not only about the efficiency of single house, it's also the efficiency of the system. So again, we are back in the vertical integration of district heating. That's crucial, really, really crucial. And it's important. And then the other thing, we are also doing a lot of work to find the water. Because if we have to do 2-point-something gigawatts of Power to X hydrolysis in the SBR area, you should use around 4 million cubic meters of water. More even. because you have to be ultra clean water into the cells. So there is a lot of water. And this inefficiency in water treatment, how to not do a environmental catastrophe, because that could be the backside. If we are not really making sustainable solutions on this power to X, the water can do a harmful situation to the environment, and that's really crucial. And there's also a lot of energy inefficiency if you're not handling technical water in the right way. So we are also working a lot on making infrastructure for technical water in the right sustainable way. So that's also a key message for these people, that you are not only having to outbuild the renewable production, but also to find good solutions for all the other things in this value chain of power to X, and that's crucial. And we are working a lot on this. Thank you.
Thank you very much, Claus Nielsen, for sharing the highlights of what you're doing in, turns out, a number of different areas, power to X, etc. So the next speaker is Christoffer Sørensen, who's the CEO of Greenlab Skive. Greenlab is maybe not the biggest power to X project that you will ever see, but it has one virtue: it exists, it's there. And the responsible for running it and developing it is Christoffer, so the floor is yours.
Thank you, Hans-Peter. Yes. Not my first PowerPoint. So thanks for the invitation, Christoffer Sørensen, and it is with an O. I'm actually from the US, but I'm still on the integration program, so I'm sure we'll figure it out, even though we're here in Denmark. Greenlab is a public-private partnership, and the idea of local anchoring, I think Brian mentioned this before. This is where this started. It's sort of a grassroots project which has grown and hit, you might say, an external momentum in the market with hydrogen, district heating, and so forth. The idea with Greenlab is to make sure that we create the best context for PTX, and that includes district heating, of course. But what do you do when it's not winter? So there's a lot of heat in the summer as well, and then we don't need the heat. So there's more to the context than just district heating and P2X, not to mention competing with drinking water, for example. So the idea with Greenlab is to build it, try it, show it, and do it better. Kind of like this plan, do it, check it, which Danfoss is so fond of. The uniqueness about us, and you can't see this very well, but we have our own power source. So we're building and paying for our own wind and solar park of 80 megawatts. So this hybrid solution directly connected to a transformer, which we pay for as well. And to do that, we had to get a special law written for a national test zone in Denmark, together with the Danish agency. So we are a national zone where actually I can blow things up with electricity and it's not illegal. That's a nice luxury, of course. But the idea is to get the data so that we can replicate across many sites. So we can generate and store and share energy. And the last piece is quite unique. So this infrastructure, where you combined the heat, the electrical, the gas, and the water in one infrastructure, and convert as needed and store as needed, calculate the buffering needed to supply the circular economy in the industrial cluster. That's the whole object of the new ecosystem. And this infrastructure doesn't exist other places yet. So even though we can call a lot of engineering companies and say, I need one of these, they'll just give you a district heating system, or a water system, or a gas system. Same. We need to recreate this. And this is the challenge, recreating the infrastructure so that we can achieve the optimal zero waste, which is what's great to see at SBR. Same thesis, but we have to do it physically and digitally. So how to calculate that and how to do it? You have to build it. So this is the site. It's about 600,000 square meters. We're expanding another 700,000 square meters, or 1.3 million square meters of industrial clusters directly connected to the wind and solar park on site. That doesn't mean we're an island. Of course, we have the cluster, and we do a lot of balancing within, but we can also help socioeconomically by balancing against the regional grid as well. So we're working with the DSOs and the national transmission companies. EnergyNet, the national TSO for Denmark, just signed an agreement with us to practice balancing and saving infrastructure in regional grids by using these clusters as a balancing agent within the total grid solution. All of these yellow spots are in operations. So large biogas plant, waste handling. We have pyrolysis plastics, back to plastics, which is sent to Germany actually. BASF is doing the offtake here. Next door we have protein extraction from an invasive species of starfish. So we have biomass extraction. And then the wastewater from that goes into the biogas plant, increasing production there. This is a separated CO2, which will be used next door in the PTX. This is running in November. So in November, we're producing the hydrogen from water, from wind, from solar, combining it with CO2 from biogas. And the first customer is mass shipping. So the e-methanol, which mass shipping is promoting around the world today, the first contract started here. And that's because we're actually producing it this year. So it's a good place to start, which means you get a lot of experience. So of course, we get the bumps and the bruises being the first ones to try it. But in the end, we'll generate the data, we can optimize, we can try the next thing out. The PTX is starting with 12 megawatts here. The first module of the next scale is a 6 megawatt module created here in Denmark, in Kolding actually. Green hydrogen systems will be delivered in November as well. And that'll be to 100 megawatts within a year and a half. So we have 124 megawatts of hydrogen working within 18 months from now, which means we can try a lot of things. Turns out e-fuels are not the only way to use hydrogen. We send the hydrogen over to the quantifuels. They need this for the pyrolysis to upgrade the product out there to be used as naphtha. We send it over to Stiesdal. Stiesdal using straw to create jet fuels. To use the syngas to jet fuels, you need a lot of hydrogen. So we have customers on site using the hydrogen produced on site. That cluster effect gives us a 70% savings on the cost of hydrogen door to door. So it's great with pipes. It's great with sending it to Hamburg. I know he's here somewhere, Carsten. And I get the calls, when do we get some hydrogen from you guys through the pipelines? Well, actually, I'd rather use it to some green growth on site. And if you look at COP26, just transition, place-based energy usage, this is how to do it. So for us, PTX is equal with green growth. There we produce the energy, also apply the energy, convert it and use it in new industries. So we have created already 100 jobs in 2 years, and we're looking at 300-400 jobs more. This is how it looks when you're drawing a diagram, very nice, so don't worry about that. The thing to know is the PTX is in a context of green industrial processes. So new products are coming out of this PTX. Over here we have commercial contracts. I mentioned the contract with Maersk for e-methanol. We have the proteins, which are replacing soya imports for organic proteins to animal feeds. We have naphtha going to Germany. We have the jet fuels going to SAS. So everything is a commercial contract, which means we can backcast that back into reinvestment and build out the cluster. So we start with the thesis, create new products to market, connect to the rest of the world, and then use that monetary advantage to reinvest into the industrial clusters, which means it's actually a business proposal. It's not a demonstrator. It's not something you have to do because it costs a lot of money and you hope it'll go well. People move in today because they save money and they have a greener profile, and we can show it on the spreadsheets. So I'll conclude, as mentioned, not just in Energy Island, we're reaching out with virtual connections. That's why we work with EnergyNet. How do you digitize connections point to point so you're load neutral across the grid? What is our role in this? We mentioned this in the last session. We have all the knowledge up here on the stage. How do you put that together? Somebody has to do that. So we propose to do that. We will build facilities as a service and invite all the components to join in, and we'll take the risk on the system integration. We put the money on the table. We've already put 2.4 billion kroner into our infrastructure and our partners. We will go out to other sites and do the same, take that risk because we know it works. And we can provide incentives of saving CAPEX to the local producer and saving time because we already have permissions, we already have the systems set up, we have the relationships to the public entities, so you just plug and play. Makes it easy. So then it's not complicated anymore, it's simple, right? I can see my faces out here. Yes, that's so simple, let's go do it. Finally, it's not meant to just be one site. We're building the whole thing not based on the particular site profile, but based on creating a matrix operations which can be adapted and agile to any site. We call it sources and uses. So once the system's up and running, we can plug and play different sources and uses and optimize across those. And the nice thing is you can use that in the design phase. So you can get a lot of things out of the way by simulating on this platform before you go and start implementing, finding out 30% of it was wrong. So that was our pitch. Thanks for the invitation.
Thank you. Thanks a lot, Christopher. As said, there may be time for a question or two towards the end of the session. At this point, I'm pleased to pass the floor to the next speaker, who is René Alcaraz Frederiksen from European Energy. European Energy is a big investor in energy projects around Denmark and also globally. And you'll tell about some of the projects in Denmark and perhaps maybe beyond. So please, the floor is yours.
Thank you. So my name is René Alcaraz Frederiksen. I started with European Energy around a bit over a year ago. At that time was to deliver a small green hydrogen project in SBR, which was presented a bit earlier, and you will see some of that. And it has been quite a journey, and I'll show that in a minute. But a bit about European Energy. There's always a lot about renewable energy and where should it be. So we have a picture here from southern Italy where we have a solar farm. There are also some wind turbines in the back. A lot of people don't like it in the backyard, but I actually think it's not always, it's ugly. I think that's a common thing, because without renewable electricity we won't get anywhere. Of course there's energy efficiency, but that's an important thing. A bit about the project. We started, I can see hamburgers on next. We started in Germany in an auto camper with some guys setting up wind farms in Germany. Before that, they had been building wind turbines and control system for that. But then they went into the development. Since then, they have expanded from wind and solar. And this year we will be putting on stream more than 1 gigawatt of renewable energy just this year. And next year even around 1.5. The other thing which I'm really excited about is we will start construction of 2 Power-to-X plants, including the world's largest e-methanol factory in Aabenraa. And we have taken final investment decision, and we will start building this year, and they will be operational, fully operational next year. So that is really exciting. You can see we are in 14 countries. I think that's 18 now. We're expanding a lot. I think last year we were 250 people. I think we just rounded 400, so the slide is already updated. So we are on quite a growth trajectory. But it's really great because it means that more and more renewable energy is getting out in the world. And even an old fossil guy like me, we can change. I worked in oil and gas for 20 plus years and developed projects around the world and optimized systems. But otherwise, we have traditional developer. We go out and find a piece of land with a community, like here in Sønderborg. There was an announcement a few months ago that we are exploring building a wind park with Sønderborg Forsyning, and we'll be building Power-to-X next to Danfoss. So really exciting about see what we can do with the local communities where we operate. Now, everyone talks about Power-to-X, but why? For those not from Denmark, we have our Queen here, and we have our Prime Minister and Climate Minister. And each year in Denmark, there's a New Year speech, and both the Queen and the Prime Minister and these were talking about Power-to-X, which has never happened before. So there is a change. And it's, I think, and this is my interpretation, it's really because we like the way we live, but we want to be green. And I think Power-to-X is one of the enablers of doing that. And because we like our juicy tomatoes, you can see it on the picture from Italy, where the picture was in the beginning. We like to travel the world for business or pleasure. We like to get our electronics from Southeast Asia and transport them up here green. So this is really one of the things. But also we have a problem with, we're developing a lot of renewable energy. As I say, we're putting on stream more than 1 gigawatt just this year. And the problem with renewable is there's either too much or too little. There's never the perfect amount. It's not like a power plant you control. So what is the solution to this? We think one of the solutions is indirect electrification for e-fuel. So, and also effective sector coupling with this is about. Because then you can run your Power-to-X plant. You don't need a big grid connection if you harvest some of the electricity yourself. The other thing, when the grid is needing more, you can calm down, you can export more. And when there's too much, you run the Power-to-X full speed. Today we're just shutting down the windmills. I think in Denmark, on average, every windmill, if you have 10, one is always standing still on average. So that's a huge wasted energy loss, right? So a bit about our Power-to-X organization. As I say, the portfolio is we have 2 plants coming. We start constructing this year, we'll be on stream next year. We have sold, we will be delivering from Åbenrå to Maersk for the first methanol fuel ship, but also for gasoline blending to Circle K. And I had hoped, but we're missing the final text, but there will also be some plastic producer, a well-known plastic producer up here soon, because actually methanol today is not used for gasoline blending and transport of ships. That's a new application, a new green application, but it's used for plastic and paint, and so all the colors in here has an amount of e-methanol in. Today it's made from coal or fossil fuel, while in the future we can start with green electricity, some water, and some air captured CO2, and that's it. And I forgot I have a bottle down there you can come and see after. It almost looks like water. We are set up in Søborg and Støvring, and we are around 25 today people. I started as employee number 1 a year ago in May, so it's quite a growth trajectory. Our project pipeline is the first 2 projects that will be constructed in Måde and Kassø, but we have 4 other kind of similar replicas in Denmark. There is Greenlab Skive, Hanstholm. It's an announcement here in Sønderborg, yesterday on Lolland and Nakskov. And the really big one is the one in Brazil and US, also for Maersk, where we will be developing what is equivalent to 0.5 gigawatt of electrolyzer capacity needed. So when I started a year ago, I was looking at 6 megawatt. Then later this year, we signed for 52 megawatt with Siemens for Åbenrå, and now we're looking at the 500 megawatt. So it's important learnings what we're getting through, and we think we need these learnings because we will fail, we will make mistakes. So that's now a bit back to sector coupling, and this is our project that was talked about by Claus a bit before in Måde, where we have some of the offshore turbines. We have been producing green electricity. We'll put 2 different electrolyzers up to test the technology and stimulate the development of that technology. But also we'll be selling green hydrogen to the port of Esbjerg, so the ships, when they come in today, it's not all the harbor that's electrified, so they can put up a power pack that runs on green hydrogen, so they don't use bunker fuel and sending that with particles into the city. And then we have one that we have a signed agreement. I can just not disclose it for other reasons, but we have another signed agreement with one of the world's largest hydrogen providers. Then, as I mentioned, of course, the efficiency of electrolyzers today of the commercially available is around 70%. When we add district heating, which is good compared to a car that has maybe 25%, but when we add district heating, we get up to 85 in the future. We think we can get above 90% efficiency. So very good utilization of the energy also. The other thing which was mentioned is the grid balancing service we will be doing. So this is really where Power-to-X helps, and I say one of the enabler for the technology. So that's a bit about our project in Måde. On what is important when you go into this project, I think it's about collaborating the full way across the value chain. And when I've been with Claus and his colleagues, it has always been, hey, we looked at how can we make this work versus this is mine, this is you, I want it like that. And I think really the mindset for any of this sector coupling is the number 1 driver. It's the mindset. I've been in meetings where I can just feel, okay, this other guy, they're really not interested. And we come out of the meeting with no success. Then I've been at other meetings where, man, they come up with ideas and so on. So it's really about the mindset of getting sector coupling. As Lars Treen from Danfoss said before, a lot of these things are actually easy. It's about doing it. Just do it. But you need the mindset to do it. So in Åbenrå, or just outside Åbenrå, we're building what we think is a true lighthouse for this part of the region. We'll start in November this year. And we have cheated because we started with the solar park. It's coming on stream here in a few months. We have done some test run. It will be the largest solar park in Northern Europe of 300 megawatt. We will build the world's largest e-methanol plant with a capacity of up to 44,000 tons a year. I have to say it sounds like a lot, but the industry where I come from, this would normally be 1 or 2 million tons a year. So it's a learning step, but an important one. We will fuel the world's first e-methanol powered container ship. And also here we're doing sector coupling, and we're actually taking from the methanol, and not from the electrolyzer, but from the methanol factory, where we can heat up to 4,000 local homes in Aabenraa municipality, and we're giving it to 2 district heating companies. So a lot of sector coupling there, and it's been really great, and we're looking at a further potential so we can heat up to maybe 10,000 homes with 100% fossil-free district heating and excess heat that would otherwise just help on global heating, but now hopefully it'll go to the houses. We have a data center as neighbor, or a planned data center, so we have a lot of focus on safety. And for that we had to change our design, so we didn't have a hydrogen storage, and we found a way to do that, a very innovative way to do that. So we store it as a liquid, as a mixture of methanol and water. And then we think this will just be a valuable learning for the green transition. I'm sure we'll fail on something, we will learn a lot. We're already learning as we design today, but this is where we are. Thank you for your attention.
Thank you very much, René. Now we are already, although 3 Danish companies and examples, so we are very international, but to make sure we are truly international, we have the 4th speaker, which is Tara Amakisi from the Danish consulate in Hamburg, who will explain a little bit about the German situation and whereabouts in PTX. So please.
Thanks, everyone. So yeah, I'm going to take you to a short journey south of the border. At the District Energy Advisory of the General Consulate of Hamburg, we saw within the last years that it has become inevitable to not to look at hydrogen. So that is a segment that we have been looking at, and I'm going to just give you a bit of teasers of what's happening south of here. So the current situation of the German energy transition is that there has been a nuclear phase out happening in Germany, and currently there is a coal phase out in process with very high ambitions on becoming coal free quite soon. So the consequence of this transition has been that natural gas has been appointed as default as a transition fuel for the heating and electricity sector. And before 2020, it worked also quite well. There has been also support schemes implemented for CHP plants, innovative CHP plants, but then the spike in gas prices happened, and also now with the Russian war, this raises a bit of a need of the reconsideration. This is where hydrogen comes in a very good place, because hydrogen has the possibility to, first of all, decarbonize the very heavy industrial sector in Germany, which cannot be decarbonized by using direct electricity. It also can work in the transport sector and heavy transport sector, aviation and maritime transport. And also, it will prevent the large amount of stranded assets which will result of the CHP support and of gas having been counted as the transfer solution, because there is the possibility to make these gas plants hydrogen ready and then operate them through hydrogen. So when we are looking at the demand side in Germany, as of today, the industrial sector in Germany has a demand of 55 to 60 terawatt hours of hydrogen, which is covered by gray and fossil hydrogen. And this is mostly for ammonia production and methanol, but also in refineries. The prognosis show that this demand is going to increase, especially in the transport sector. So that's where in future there will be the highest need for this fuel, and thus the highest value. And in order to also facilitate this transition and the use of hydrogen, Germany came out in 2020 with the National German Hydrogen Strategy, where they have ambitions to expand the capacity of electrolyzers to 10 gigawatt in total by 2040. And there has been 9 billion euros set aside for this, the majority of it targeted at the steel and chemical industry, because this is where currently there is a high consumption of gray hydrogen. So the first step would be to green this gray hydrogen. But there's also in the money set aside for expanding the capacity and then here we come to the global view in global cooperations. Because hydrogen, it's a global task. It's not a local task and the energy transition as such as well. So the strategy is going to ramp up the uptake of hydrogen in the German energy system. And if we look at different sectors, so and what role hydrogen plays in them and will play to them in the industrial sector, there is a high CO2 mitigation potential in the steel industry. Like I think approximately they foresee a demand of 84,000 gigawatt hours per ton per year for the steel industry of green hydrogen. So that's a very large demand sector. In the transport sector, for the aviation especially, there is a lot of research going into hydrogen fuel cells. So, and taking into account that there is many different possibilities to green aviation fuels, and having a specific fuel cells, it's a path that they are looking very much into. So there is a lot of potential there. And of course, the local communities are also very active in setting up fueling stations and establishing for large trucks a fueling network for hydrogen fuels. And there's currently already 156 existing and operating. And when we look at the heating, this is the large difference that we have in Germany and in Denmark, because when you look at the Danish strategy, heating is completely excluded. But in Germany, hydrogen is part of the heat transformation parts. And that is mainly because of the different demands and the heavy industries that are there. And also because of the issue of CHP plants and stranded assets. So that is a large difference we see with Denmark. And but this is not directly encouraged or discouraged by politicians. And what I mean by that is there is still higher costs for the implementation of electrolyzers for heating compared to in industry. So the costs are very high. And but on the other side, also within the national strategy, the heating sector is not focused on, but it is mentioned. So, but the heat transformation plans also leave it very much open to the communities, how they want to decarbonize their heating. So it's not, there is no ground rules giving top down, but it's a very bottom up approach. And depending on the needs of the community and the resources, there's different, this causes different results. But at the end of the day, Denmark has the strengths and the technologies, and it is 2 billion euros are set aside for international cooperation, and I think Denmark as the neighbor up, like in the north, can play a good collaborative partner there. Thank you.
Thank you, Tara, and I can assure there's a lot of collaboration also in this area taking place between German and Denmark partners. So I'd like the four speakers to come up here because we have time for a couple of questions from the audience. So please, if you would care to stand up here. It may inspire someone to put a question to some of you. So the floor is open. Anyone with a question? Yes, please. Carsten.
Yeah, this is for you, Tara. So you talk a lot about the hydrogen and using that for different purposes. I will not dig into the heating part, but I mean the waste heat in the process, because this is also about sector coupling. Is there high ambitions of doing this sector coupling for district heating, so you actually increase the efficiency, like European Energy was talking about?
Yeah. Definitely, because the waste heat is also a factor in the feasibility of these projects. So there is also plans to use that. But in practice, it's also the question of where these plants are built. If they are built near offshore wind parks, then you usually don't have a city right next to it. And But it really depends on project, but it is definitely something that is very much a part of the whole plan.
Thank you. Other questions from the? Yes, please. There's one there.
Hi, this is Fritz from California, and we are very excited to be here to learn a lot about what you all are doing in Europe on hydrogen. And I was curious, we are developing a potential renewable hydrogen hub, but we are realizing that we probably will not have enough hydrogen based strictly off of renewables. I'm curious, what is the appetite for CCUS and hydrogen, or is it more of a direct transition, just go straight into renewables?
Anyone venture? Yes, Christoph.
We've been looking quite a lot about that, and we have many colors of hydrogen by now. We even have pink, I discovered recently. And I participate in the Hydrogen Council in the EU, where you're trying to treat this as a strategic effort. The challenge is between encouraging the full transition to green hydrogen versus delaying that transition by using natural gas, that we speak of, or blue hydrogen. And because we have such strong embedded market structures in the oil and gas industry, the longer that we delay with carbon capture from oil and gas sourcing, the slower the transition will be to the fully green hydrogen. So there's an embedded challenge in these competing market structures. And our thesis today is the more we incentivize the green hydrogen, and we are working on certification processes end to end to do that, the more we incentivize that, the more acceleration we'll have towards that objective. And I understand the limited resource of amount of renewable energy, but as we discussed today, also energy efficiency and sector coupling can have a large impact on how much renewable energy you actually have to apply. And I think the earlier analysis from Brian about how you can use the heat pumps and the other sourcing in a very interesting way could help reduce the amount of direct inputs to the hydrogen needed. But we understand the conundrum. It's an inbuilt challenge. We suggest to accelerate the green hydrogen efforts.
Thank you, Christopher.
Yeah, Lars from DI. Thanks for excellent presentations. I think very inspiring. And just to you, Christopher and René, if I may ask, and you can reveal what you want to reveal, but can you tell us a little bit more about the business financials? I mean, you didn't touch that, a lot of technology here and what you're doing, but what is the business case here? What's the returns, what's your structure and your business model for an investor perspective?
And that's actually quite interesting. I get calls from capital funds all the time now. It turns out it's a good business. And we're a non-profit public-private partnership, so that's not our intent. Our intent is to incentivize the transition and participation. But it turns out you can gain more green energy cheaper by doing this cluster model. Excuse me. The trick is that somebody has to act as the integration platform. And nobody likes to do that, whether it's ABB or Siemens or all the big companies which I've worked with in the past. They don't like the system integration risk profile because you have two sides of every integration. So one side can always go wrong. That's like twice the risk. So the challenge is to create this integration platform which enables all of the technology partners to just plug and play. That business model then, in fact, reduces CapEx, reduces time, which accelerates the ROI or the IRRs of those participants. So far so good, there's an incentive. But then how do you get the system integration platform returns? It turns out that if you do that at a cluster and you have one point of contact to the grids and the connection points, you can actually create an internal market based on a distribution tariff, which is, if you look at a 40-year return on your investment in infrastructure, you have a different time frame than the 20-year factory returns on investment, which means you allow yourself to go in and make a return on investment which is very sensible over a long term by investing in the infrastructure and doing your own internal tariffs based on a plug-and-play model. So it's quite feasible, it turns out. It's better than I imagined 3 years ago when I did the spreadsheet.
I think one comment I can add is, I mean, we have today, I work not as project developer, more in the economics and optimization side, so I spend half of my time with banks and with investors. And I think what I maybe didn't mention was that we have done these two projects you see without any subsidies. We just were granted a small one here yesterday, but that was for some heat integration. But for the main product, we have been able to do it without. But also we have done a lot. So if you find the right spot and the right value chain connection, you get the right partners, we have actually been able to do it. Does it mean we can do it in big scale all over the world without subsidies? Maybe not, because there's also the customer. But we have found we found the customers first, and by then we could develop the project. We had a clear target, and that has helped us. I cannot comment on the IRR, of course, but.
So if I supplement René, we work together at the Greenlab site. One thing I think we've learned also from Greenlab is the structure of the offtake contracts needs to have some variable component based on the input streams. Otherwise, you get caught in a clench between, for example, price of electricity, price of hydrogen, price of methanol. So these structural elements to go to market are quite important.
Thank you.
And I can tell in a developed area where we have the infrastructure in place, we can utilize the same infrastructure. Mostly of what we are doing in SBR is utilizing the existing infrastructure. If the policymakers do good environment for district heating companies, instead of saying, oh, everything should be competing and individual rights in every household, do the energy planning and stick to it. Then you have the infrastructure ready for infrastructure as a service. We have this. We have the water system. We have the heating system. We have the gas system. But we should protect these valuable assets, because this assets is going away if we are not giving the right incentives to keep the investments, and they can be utilized also for the future. It's not new infrastructure. We can do this transformation in the existing environment. So instead of it, I really like Greenlab, and it's perfect for greenfield, but we can do the same transformation in the existing areas. So we can do this for existing factories in the existing areas.
That's an even better business, actually.
Yeah.
If you start with the infrastructure and repurpose.
Yeah, that's just normal thinking in Jylland.
So you have some pipes you like to.
Okay.
Like Sønderborg. Yeah. It's not.
It's not rocket science.
No, it's not rocket science. We don't need Silicon Valley ideas. It's
the energy metropolis. Yes, yeah. That's it. You know, I'm in trouble because I have 3 marks down here. So if you can put your, okay, then I have 2. 2 very brief questions and very brief answers, please.
Yeah, so thank you for sharing all the knowledge in this room. I'm JP, and I'm from the Google data centers, where we are trying to find out R&D for our infrastructures around the world. And one of the problems that we really have is fully support of the sector integration, but it's kind of like this power to X. What is that X going to be, right? And I think there's a lot of speculation in that right now. And you know, you have an existing fleet out there of backup generation, you know, like power you need. And for that reason, you know, we are investigating right now, should we go direct with hydrogen and PEM fuel cells, or should we go with some other technologies where we actually talk about e-fuels? And I'm a little bit interested in both you, Christopher, and René, what do you think about that X should be right now for the existing fleet, and how you want to approach this going forward?
I think it really depends on your use, so we can have a conversation after, because they each have their rights. Both are needed, or all are needed. So it's really about are you looking for a backup system? Are you looking for continuous running? You know, what is it you're looking for? And I think that where are you in the world may also decide that. What is your neighbor?
Now, I would suggest the co-location factor is critical, because the door-to-door delivery means you have a matching exercise. So we have a 70% cheaper hydrogen on-site than if you deliver it, you know, to another site, because of the savings. But you can see the developing matching exercise going on over the next 10 years, as a shipping to ammonia, for example. Because where does the CO2 come from methanol? And I was about to ask that about your projects. Where does the CO2 from? That means it might not be CO2 neutral, actually. So this is a critical element, is where you're going to maximize for CO2, you're going to maximize for your economics, or you're going to maximize for the global matching exercise between sources and uses of these types of energy. And I think Google's a global entity, so they should be thinking up at that level at some point.
Thanks. So I think the short question was like a math question, what is X? And the answer was not conclusive.
Google X.
Yeah, Christian Heine from the Hamburg Energiewerke. Also, many thanks for your exciting presentations. I have a question on the business model again, because you said you have your hydrogen power, hydrogen purchase agreements at the moment, so direct contracts with the customers, I suppose. Are there any plans in Denmark to establish a market platform for green hydrogen, and what would be the time frame for it?
I think what I know Energinet is looking at, that's the national transmission company, so they have electricity, natural gas pipeline. They're looking at it, but it needs to be, and I know people are looking at it at a European view, but I would also say, from my own experience, I was in France in October for the Hyvolution. There they look at it, hey, that's great in 2040. So will we get, we may also get to the border of Germany, and then there's no link maybe to Hamburg. So there is some, and I think that's about sector coupling. It's also infrastructure, probably more that's needed, because otherwise and that's a part of when we evaluate where do we put a Power-to-X plant and what is that power to, what is the X? It is, we look a lot on infrastructure, because it is missing, because it's a new.
Thanks a lot. Yeah.
I could supplement. At Hamburg, you have a great port. So this, the synergies you can create out of the industrial and energy complex, including logistics in and out, because we've been speaking with Hamburg, that allows you, if you get the right energy sourcing, which is your challenge, actually. It's a crowded space. But other than that, we are starting, for example, a local, regional hydrogen infrastructure, because we have offtake in these clusters, really close to each other. When you get to the larger distances, that's where the challenge is either time, regulations, or collaboration. So we see a much stronger advantage in co-locating as much as possible. And you have a lot of good resources for renewable energy in the northern Germany in particular, which we think could be the best application, with synergies in logistics and industrial clusters like Hamburg.
Thank you very much, all of you. Thank you, panel, and thank you, participants in this session. A few practical remarks. Now there's lunch served downstairs. At 12:45, buses will leave, and you may be signed up, and if not, you may be even dare and venture and go outside, jump onto a bus. One will take you, the one that I know best of, will take you to Superbrusen, a supermarket utilizing surplus heat to heat up the store and the surroundings. So that is 12:45. It will be announced down there, but don't be late, because the bus will leave 12:45. And it will bring us down here, back again for reception and a few closing remarks at 2:15. As was said in the beginning, we need a pixie book to explain all of this, and this is a list of 6 pixie books. Some of them are available physically downstairs as well. White papers explaining district heating, explaining energy efficiency in buildings and so forth. So please have a look at those downstairs. That being said, thank you again for being here, sharing your knowledge, and I hope the conversation will continue downstairs and throughout the day and onwards. Thank you.